All right, and we're back for a very special Shop Class Podcast episode. Tonight, we have Mark and Calvin from Paragon Machine Works. How you guys doing?
They're doing well. Yeah, doing good.
All right. And we also are joined by a round table of experts. Tonight, we got Mark Adams in the house, photographer. How you doing?
Good.
And motorcycle rider and also an amazing photographer. And we got Peter Molinaire. He's from Toronto. He works on Passive House, but he also could do anything from machining to roofing. I don't know, everything in between. How you doing?
Pretty good today, thanks.
All right. And special backup support guest is machinist and educator Jenny Bannock. How you doing?
I'm fantastic,
All right.
as per usual, right?
Cool. And we're all in our shops. So I've got the Tormach behind me, inspired by all the cool stuff going on at Paragon Machine Works. And Jenny's got a couple of Tormachs and a couple other things. There you go. And but tonight we're gonna talk with the two people that supply the industry with everything but the tubes, all the frame parts. So let's start out with some context because not everybody understands that part of the industry. Most people just walk. I mean, I worked at a bike shop. They walk in, they want the toy bike, type of thing. But there are people that consider bikes their lifestyle, and they really want to make an incredible bike to ride. So just like a tailored suit, they make a tailored bike. And then there are people that specialize in making this tailored bike for you. And tell me if I'm describing this right. You supply all the pieces that make that possible besides the tube. Can you guys explain? How would you describe it?
Yeah, that's correct. I'll hand it over to Calvin because he's got to get good at this stuff.
Yeah. I would like to explain it like this. So we basically, if you were to take just a bicycle frame, besides the tubes, we make pretty much every other component you'll see in that. That could be a dropout, a head tube, a bottom bracket shell, any sort of little threaded boss or eyelet. We don't really do any direct-to-consumer products. We also don't do many products that are interchangeable. I would say the only products we have that you can realistically remove and replace from your bike would be hangers, inserts, and maybe a couple stem parts. So generally, if someone's buying our parts, they're welding a bike themselves and they're never planning on taking those parts off.
Okay, interesting. All right. So this is the stuff that stays.
Right. So yeah. So what you've got right here is the bottom bracket shell, and I consider this the foundation of the frame. This is where it all starts. This is where your cranks go, where the cranks and the pedals and the power goes into the bike here. And then the rest of the tubes are connected here from the foundation, and it builds up from there.
Nice. Now, so can you describe, like, of course someone could make this, but are they going to make it as accurate as you and as often as you? Would that be the service you're providing? They don't have to be great at machining. They just need to weld this thing together. Am I right?
Yeah, I think where we have an advantage is that we're making large quantities of parts. So we may spend just as much time trying to get our first part to turn out well, but once we get to that point, we're able to solve our material, load it into a bar loader if it's a lathe, and just run that thing. So you start to really drive the cost of each part down as you make more and more and more. So we're able to provide a product that is very cheap. I mean, if you were to, what's your time worth, right? And even if it's, something low, like $10 or $15 an hour, it's like, we can provide a product that would probably take you a few hours to make, and it's going to cost a lot less than that.
So can we go through just this one part? Because seemingly simple, but I'm guessing this is not that simple. You first have to get an accurate tube, and then you have to machine it in several areas. So do you want to just roll through this? And this is really like $12, and boom, you got this bottom bracket.
Well, how detailed do you want me to be? Because I could go into an incredible amount of detail.
Well, start with the people that don't know anything. And
Okay.
then, yeah, because imagine there might be students that watch this that love bikes, but they might not know that this is an option for them. You know, they might modify bikes and they work on their bikes. And for some reason, the kids always forget about brakes. Those are always last. You know, but
That's what feet are for, right?
yeah, what's
That's what your feet are for,
oh, your feet,
right?
Or your face.
Yeah. No?
Yeah, we actually have the
Or your
hill.
face.
Yeah, I teach in an urban neighborhood, and we're on the edge of the Hudson, and it's not like New York where it's gradual. The Jersey side of Hudson is a huge 300, 400-foot shot up, and then there's a city above that. But there's always a road that brings you down to the shore, and the kids go down that, and they come in with like elbows bloody and from the day before, and I'm like, what happened to you? You get into a fight? And they're like, nah, 60th Street. And I'm like, let me guess, you got no brakes. They're like, well, I just kind of put my foot back there, you know. So Calvin, basically, you know, the kids love working on bikes. That's like a natural, kids and bikes go together, but they might not know the detail that goes into the manufacturing side. And they also might not know that they can make their own. So yeah, so start with the basics and then give us some more.
Okay, so I guess I'll describe the process on a CNC lathe, and I'll also assume that most of the people watching know what a CNC lathe is and generally how it works. But the first step to make one of these parts would be the setup. The setup includes loading your programs, depending on how many that is. And in this case, it's just one program for a bottom bracket shell. Next, you got to load your tools. And I think generally for these, we have about 7 different tools to make the final product. Then you need to set up your work offsets and basically tell the machine, well, where is the front of my part and any other important general dimensions. If you need a second work offset for, if you happen to be pulling the part out twice, you need to define 2 different positions for your material, for your face. That could be a useful scenario there. So once I have all of those in the machine, I'll, you know, get my spindle nose in, my collet, get all the stuff that I need to into the machine to let me run whatever size material I have on hand. And then it's a matter of very carefully testing your program for the very first part and making sure that you are not missing any tools, that your work coordinates are correct. It goes very slow initially, but hopefully by the end, maybe 2 to 8 hours in, depending on how complex the setup is. And in this case, these generally take me 2 hours. You'll have a final part. And I guess I should also probably explain the order of the tools, because that is also a very important aspect of this.
Let's take it in stages. So, you know, people might not know what the lathe is, you know, and basically I describe it as it makes all the round stuff, and and then the milling machine is all the stuff that holds the round stuff. So it's kind of male and female in a way. And then, you know, Jenny, how do you speak to your students in a layman's terms about a lathe? What do you describe it as?
So I talk when I'm explaining the difference between a mill and lathe, I talk about spindle orientation. I tell a lot of people that lathes are like a mill that you tip on its side and remove one of the axes. And I usually differentiate, although this isn't always the case, but I also say, you know, with a lathe, you're spinning the workpiece. With the mill, you're generally spinning the tool. And the lathe only has 2 axes because it really only needs 2 axes, because when you do a program for a lathe, and you guys know this, you're really only doing half the profile because it's spinning around. So, but for me, it's really what you're spinning versus what, there you go. Now, you have to be careful saying that too, though, because there are mills that are horizontal. So, you know, I tell people it really just depends. But if you're looking at like a vertical mill versus a lathe.
Okay.
You get the cool graphics.
Oh, I don't know. I just typed in animation.
I thought you just made that. I'm like, I'm impressed. Wow.
Oh, that would be cool. Yeah, that would be cool. Okay, so now, all right, so now walk us through so that you have this lathe operation, and Calvin, you were going to tell us about the different types of tools. Is that right?
Yeah. So the first tool that I generally like to use when making bottom bracket shells would be my first of 2 boring bars. What a boring bar is, it's just a really long tool. It can be a couple inches up to over a foot long for us, for our applications. A foot is a really long tool, and you will start running into issues potentially like chatter or deflection of the material depending on the stick out of each of the tool and the part. But what the boring bar does,
Here's boring right here.
I got the boring.
Great timing.
yeah, so this is a boring operation, and you essentially insert the tool into the material, and you can turn towards the spindle or away from the spindle depending on where you want your chips to go, whether the chips are breaking. It looks like they're turning in here, and it's probably because they had a very small clearance hole, I would imagine, so it's just easier to feed straight in. Looks like they put a little counter bore in too, and that's essentially what we do on our bottom bracket shells to relieve the ID. Is we just take out as much material as we can, so it's a nice light part, and set ourselves up well for the second boring bar, which will finish that inner profile and make sure that the major diameter of our threads is correct, and that there's enough room for the actual bottom bracket. That is essentially it's a bearing that goes inside of the bottom bracket shell, and that allows the cranks to turn with pretty much no friction.
Mm-hmm.
I have to ask a real quick question, because you had mentioned some of your boring bars being a foot long. What kind of diameter are you talking? Because that has to be a fairly decent sized boring bar, right? At a foot long?
Yeah, a foot might have been a slight exaggeration, maybe like 10 inches. What do you say?
Yeah, 10 for sure, and occasionally we use them as long as a foot. And they'll be an 1.25 inch diameter, occasionally even 1.5 inch diameter. A lot of times we use a solid carbide bar to minimize vibrations, and then there's a boring bar that actually has a little slug of metal inside it. That the theory is it counteracts the vibrations or the chatter of the boring bar. And that little slug can get moved back and forth, and it's tunable. So you can play around with it and try and set up an opposite harmonic of what the machine is trying to do to you. That's kind of the advanced class.
So is that kind of like a steady rest, or is it?
No, it's all internal to the boring bar.
Oh, it is. Okay.
Yeah.
That's pretty cool. Yeah, I mean, what I tell students about machines like this is that their iPhone is user friendly. It's like a soap bar. You really can't mess it up, no matter who you hand it to. And then,
I don't know. My dad would say otherwise, I think.
Oh, okay. And then, these machines are user responsible, not user friendly. So you do have to consider every aspect, if there's going to be some sort of vibration, you might want to consider counteracting it. Yeah. So it's not just like plug and play and turn it on. You're in charge, and the machine doesn't care what it's cutting, So pretty cool. Okay, that's cool. And so then how do you choose the, layman's terms, are these bearings all threaded, and is that what sets it up? You just choose like a standard threaded size?
The bottom bracket shell?
Yeah.
Yeah, so there are a few standards in the bicycle industry when it comes to bottom bracket shells. I think a few of the most popular would be the T47, which my dad actually helped to create with a few other companies. Who else was involved in that?
White Industries, Chris King, a couple bicycle manufacturers, Engine Cycles in Philadelphia.
Yeah. So it was definitely a joint effort, but a T47 is called a T47 because it has 47 what is it, threads per inch?
47 millimeters diameter.
47 millimeters diameter.
And the T is threaded.
Yeah. Okay. See, I mean, there's so many standards even I can't.
I found it. Is
Yeah,
that
that's it.
Yeah.
So that's the bearings in a sleeve that thread into the bottom bracket shell that we manufacture.
Yep. Yeah.
So, it's changed a bit since the loose packed ball bearings that you see on all the consumer bikes. Oh man, I changed a bunch of those. You don't get it right, it's like it's garbage. Oh man. So these are kind of like cartridges. They go in, right? And just
Exactly. Yeah.
Yeah.
Nice.
And a really important thing to note about bottom bracket shells regarding this is the threads. There's actually a left-hand thread and a right-hand thread, and the reason is because you are pedaling on a bike, and so if you had the same thread on both sides, on one side you'd be turning and it would want to tighten, but on the other side, because you are essentially 180 degrees rotated throwing it in, it would actually want to loosen it. So that's why you need a left hand on one side, a right hand on the other, and an issue that any machinist or builder could run into would be either putting the threads on the wrong side or not marking which side is which. We put a little groove on the face of the left hand thread, and in that photo you'll actually see there's just a little, maybe 5 thou deep groove, maybe 10 thou wide. We use an engraver for that. And that's to help builders identify which is which, because we sell to people who are making $5,000 frames, and if we don't send them a product that they know how to orient, it could ruin the frame. And so we want to make things as easy as possible for people.
And is that right on the face here?
Yep.
Oh, okay. How do you engrave it, with a laser or something else?
We just take, standard, I think it's a 60-degree flat tip engraving tool, 1/8 inch diameter.
Oh, wow.
And, you set it up in the machine. You have to have the sharp edge facing the opposite way of which your material is turning, because it's an engraver in a lathe can only cut one way, unlike on a mill where the tool's actually rotating, so it can cut in any direction you want to. But here, you need to actually orient it in a specific position, and I've chipped a few forgetting that. So.
Oh, nice. I want to take a sec to introduce Corey. How you doing, Corey?
Good. How you doing?
All right. Corey teaches buildings and trades. Is that in Iowa?
Yep. Kind of north central Iowa. Yep, you bet.
And it's at the college level. Is that right?
That's correct. You bet. Yep.
So
my virtual background behind me is the house we're building this year. So.
Oh, that's amazing.
Yeah, all with SIPS panels and yeah. So kind of a fun project.
Turn your camera horizontal.
I don't know if it won't.
Oh, it's a virtual background. Anyway.
Oh, there you go. Yeah, it's just a virtual background.
I was going to say, where are you at where it's still daylight?
Yeah, that'd be nice.
Yeah.
I took that picture. Actually, I took that picture this morning, so it's pretty recent.
That's a great place you're building. Is that a duplex, like a
Nope, this is a single-family home. It'll have a finished basement, and it's well, when the basement's finished, it'll be 5-bedroom, 3-bathroom, probably 1,850 square feet, 2-stall garage. So yeah,
that's great. So now, normal, college class, they don't, go to the job site, but this is on the job site. Am I right?
Absolutely. Yep. We try to make it as real life as possible. The students last year actually designed this year's house, and so it's kind of a fun way to design, build the whole works. So
wow. And are you doing any passive thermal breaks and whatnot?
Yeah, the entire main floor of it is all SIPS panels, so structural insulated panels, and then the foundations, insulated foundation made by Superior Wall Systems. So kind of a neat concept this year. We try to change it up every year if we can, and it kind of depends on what we're building it with a partner with the city. They're financing it, so we're kind of trying to stay within their budget allotments and stuff, but we were able to do some kind of neat stuff this year. So yeah, it's pretty fun.
That's cool. Yeah, so a lot of different types of shop teachers join, and Corey, did you? Our guests tonight are specialized in the bicycle industry,
Yep, absolutely.
Yeah. Did you ride bikes? Are you into it? What do you do?
Oh, absolutely. Yeah. I never got like huge into it, but I spent my entire childhood on a bike, and I still ride with my kids and stuff these days too. So it's a lot of fun. Yep.
Okay. And Calvin, we're getting a little echo, so I just muted until we turn back to you guys for just a sec. Also, just want to introduce Duke Lazowski. How you doing?
What's going on? Running around. Everything's good.
We didn't even get to the first question yet, and
Seriously?
we're just kind of warming up, talking about the bottom bracket of a bicycle. You know, like where the cranks go, and we were getting into details about the lathe and whatnot. And we got Jenny Bannock in the house, and Peter was gonna sub in for you, but now that you're here.
He's my relief pitcher.
He's the relief pitcher. Yeah, we can still have him do it if you're up to the task.
We need some theme music when
Yeah,
Peter comes in off the relief bench.
Yeah. So we're warming up to it. Let's finish up the bottom bracket there. So just kind of finishing that up. And that's like got to be, is that one of the most simple, not simple like in a bad way, but like the most simple, elegant designs you guys have in your lineup? Everything else is probably complicated from there. Am I right? Oh yeah, just hit unmute. Sorry, it was because there was an echo. Probably there's a little button in the middle of the screen, and there's like a microphone or the space bar.
Got it. Okay.
Okay.
Got it.
Yeah.
Sorry, I thought you had control of that.
No.
Yeah. So
One way I can mute it if I hear echoing, but I can't unmute it for whatever reason.
got it. Yeah. I turned down my speaker. I think that's why it was feeding back. So I hope that's better. But yeah. So far we've covered the boring and we've covered the threading. Those are two of the main features. To answer your question quickly, is it one of our simplest parts? I would say lathe parts for us they seem very simple. If you were to look at it, you might say that's just a tube, or in this case, it's a tube with a thread. But due to the nature of the part, and like my dad said, how it's basically the center of the bike, it's really important to get it right. So as straightforward as it may seem to make, and probably is once you get a handle on it, it's also really easy to get overconfident or not take a simple factor into account like chatter or a chip in a tool and churn out a bunch of bad parts. So it's kind of yes and no is the answer to your question. I will say I think it is one of the more elegant parts on a bike, especially because the process is so simple to make them, but simple doesn't mean easy. Simple just means that it's straightforward.
Nice.
Yeah.
So yeah, it's where the cranks go.
Yeah,
Oh, sorry.
exactly. No, you're good. And so at this point, there's just a couple of features left, and they're relatively minor. After the thread, what I will generally do is take a one tip, in this case, steel insert, probably a V insert of some kind, and just face the front of the part, taking 20 thousandths of an inch off the front, so we get a nice flat surface. And then as I'm feeding up out of the face, I'll just go up and back a little bit to hit that front chamfer, so we don't have any sharp edges. And then I'll go up, 50 thousandths of an inch, and then wrap it to the back of the part and put a little back chamfer and create a little groove for my parting tool. So that kind of takes care of the second to last feature, the last one being the engraved line, which we already discussed a little bit. So after all of that, it's just a matter of parting your bottom bracket shell off and QCing it. So that's why I'd say it's a pretty straightforward part, because there's not a ton of parts that we make that only require like 2 or 3 styles of tooling: a boring bar, threader, and then I guess for turning insert and then a parting tool. But realistically, you could face and chamfer this part with your parting tool. It's steel and it's such a small feature that that could probably be a good way to save time, honestly. But you might see some wear on your parting tool at that point.
Nice.
So, Calvin,
Go ahead, Penny.
question: Do you start with tube stock or do you start with solid?
Yeah, that's a great question, and it depends. In titanium, for some of our tapered head tubes, which are
Let's stick to bottom brackets.
oh, I'm sorry. Yeah. In terms of bottom bracket shells, yes, every single bottom bracket shell, I believe, is made out of tubing. There may be one
Stainless steel.
stainless steel. That's the one where we can't get tubing for it. But yeah, steel and tie, it's all going to be tubing.
Okay,
Nice.
and like on this piece, it looks like you didn't have to finish the OD. Is the OD raw? Okay.
Calvin, if you have access to that space bar, just use the mic when you need to talk because there's a bad echo.
You got it.
Sorry, it's a maintenance thing. Sorry about that. You're gonna have to hit it every single time.
Yeah.
Okay, cool. So, I think it would be cool. Obviously, we get to the main question of the night, but before we do that, I think people still need some context. I think this is a good segue. So, this is clearly one of the products that you guys engineer and manufacture. But let's talk about Paragon. Maybe Mark, would you like to give us a little background? I mean, I remember hearing some stories of how you got started, but it'd be great. You want to give us a little background on Paragon?
Sure. Let's see. So I started with bicycles. I got my first bicycle, loved bicycles, rode bicycles. And then, of course, like all kids, I took my bicycle completely apart and figured out how it worked and put it back together again. And then, so that was a bicycle part. That's a really natural thing that most kids have. What got me into the machining end of it is we're hanging around with a family friend who had a bronze cannon, and he gave us a pound of black powder and a bunch of fuse and said, go have fun with this thing. So we went out and blasted this cannon off all day. And at the end of the day, I said, that's the coolest thing I've ever seen. Where did you get it? He said, oh, I had a machine shop make it for me. And I'd never heard of a machine shop, even though my grandfather was a machinist. And there was like this opportunity, like a machine shop. You can make stuff. You can make cool stuff. You can make explosive stuff. And it's really fun. So I was, that was probably 7th grade or so. And as I went into high school had a machine shop class. So I signed up for it. I had no idea what I was getting myself into.
Wait,
but I knew
I gotta hit pause. I gotta hit pause because that's the question. So hold on. So this is what we'll do. We're gonna turn it over to Duke for the most important question of the Shop Class podcast.
Wait a second, though. There's 2 of them.
We gotta hit both of them, but one at a time.
We can say one. We know one may have messed up the question, but there's still another.
Yeah. So we'll do one, and we'll give Peter the Calvin.
Yeah, that's a good idea.
Okay. So Duke, you gotta ask it to Mark.
All right, we gotta rewind a little bit before you said anything. Mark, did you have shop class growing up?
Yes, I did, and it was great.
Awesome.
Should I carry on from there?
Yes, please.
Okay. Yeah. So we had shop class, and let me go off a little tangent on the shop class. So the shop class is not just a collection of machines that are sitting there. The shop class works because of the teacher. And you have a good instructor, you have a good class. And we were so fortunate to have a machine shop instructor, Ben Bolt, who really, he worked well with the kids. He was a smart guy. He knew what he's doing on machining. He understood that we had zero ability at all. Yeah, he was very patient with us and really got the message to us how machines work, how precision measuring works, how to design a part, how to machine a part, and the whole process. So so the shop class was fantastic in my personal situation. And again, that goes back to the teacher. And all through my schooling in machine shop, I was fortunate to have really good teachers.
Nice. That's awesome. Yeah, good to hear. You know, it's kind of true. It's like you can have all the equipment or none of the equipment, but if you don't got the teacher, it's not going to work. And you know, and actually, a little segue into Jenny. You guys know I'm a shop teacher, but Jenny is she's kind of an unofficial shop teacher, and she's going to be teaching kids about machining. And what a great thing to have a woman instructor teaching machining to the kids. And I think she is a kid at heart, so this is a good move. Yeah, Jenny, have you set up any workshops coming up? You got to let us know what's going on.
So I did get word, and I don't have the dates finalized yet, but I have some friends over in the Colorado area that sell Tormach equipment. I'm actually going to go help install 5 machines and do some training in Denver, hopefully within the next month or so. I'm also doing a short class for a school here in Madison, just kind of an afternoon, trying to get their teacher up to speed because they got a new machine. And he's like, I'm not sure where to get started. So I'm going to pop over there. But for the next few weeks, I'm just building molds and repairing my machines. So they're not, or not really repairing, just getting them qualified to make sure that everything's repeatable. But I do also have some news. I've been working with a group in Tennessee that's a business incubator, Roane State Community College, and they're looking at bringing me back for 2 more sessions. So I did a class for them last fall, and so I'm the traveling shop teacher for right now, but
wow,
I'm excited because I love working in my shop, but I love being around people more. I mean, I do love, my dogs, they're people, but they're, you know, they're kind of sassy.
You know, I want to kind of emphasize something that Mark was saying is that, you know, it's the shop teacher, but who's training the shop teachers? And so that's a good question going forward. You know, the teacher trainers, you know, not all the shop teachers are kind of just right out of the box good. It takes years to develop, and some of them either give up or kind of, you know, go flat where they just hand out paperwork. I took over for a guy who was literally handing out paperwork. I couldn't believe it. So who's teaching those people? And maybe that's a topic we could talk about going later in the episode. But for now, maybe we'll get back to the Paragon story. Mark, you want to take it from there?
Sure. So the Paragon story. I was in high school, took machine shop. I got to my senior year, I still hadn't made the Canon. So that was one of my last projects. And my teacher had to come over to the house and get a signature from my folks that my parents knew I was making a potentially deadly weapon. But it was great. I've got the Canon. It's here at the shop. I don't blast it off anymore because the cops come around every time I do it. So it's taking a little fun out of it.
Wait, where is it?
It's in the tumbling room. Cool. But anyway, so after high school, I didn't really have any plans for college, other than I really liked making stuff. I liked shop classes, and our local junior college had a machine shop program. It was a 2-year degree program. You know, you take all the requirements and you get a degree out of the whole thing. So I went and signed up for that and had a great time doing that. And in the 2 years there at the junior college, I learned far more than I learned in 4 years of high school, just because it was a much more, the class was much more oriented towards, much more career oriented, which was really a big change for me. So I was finishing up that program, and I still didn't know what I wanted to do. And so my machine shop teacher said, "Hey, do you want a job in a machine shop?" And I go, I guess so. Sure, I'll try it. So I ended up working in a machine shop for 3.5 years. And that was, it was a combination manual shop and a CNC shop. This was in the late 70s and early 80s. We had some early CNC equipment there. And again, the same thing in my time there, I learned far more than I had in all my previous schooling, because it was a production environment. You know, you had to get the work done or you weren't going to have a job anymore. And I learned a ton of stuff from the two owners of the company, who are both very good manual machinists. I learned a lot about manual machining, and that was where I first got exposed to programming and setting up and running CNC mills. And that was really, really fun stuff. And it still is fun stuff. So I finished up, worked there for 3.5 years, went back to college because I wanted to take some fun classes for myself. So I spent a few semesters taking art classes and math classes and language classes and just goofing around. And I went back and visited my old boss. And one of the conversations was, why don't you start your own shop? And it was the same thing. I was like, never crossed my mind ever.
Can I ask, why did he ask you?
Why
if
did
you
he
wanted to
ask me?
start? Do you know why? Did
well-
he feel that you were a good fit for something like that?
Yeah, he did. Also, as it turns out, he had a lot of customers that were bugging him for job work he didn't want to do. And he said, you know, I'll even send some work your way. And some of the work, maybe some of the people didn't pay quite as well as they could have. But that got my foot in the door. Yeah, he said, why don't you start your own business? So I talked to a bunch of family members, and they were either silly enough or prudent enough to loan me some money for the down payment. And I bought a mill and a lathe, manual mill, manual lathe, and put them in my folks' basement. My folks' basement had 3-phase power, which is pretty odd in a residential area. And I was there for about 9 months before I had to move out. The business grew to the point where I was just making so much stuff. So
Wow.
a share rental with another guy, and pretty soon, you know, the shop grew to the point where I, you know, basically said, you got to go. I need all the room in the shop. And that's when I got the first CNC mill. And then, you know, from then to now, it's been growing every year. The bicycle stuff was one of the first stuff we did, but we always did job shop work, and we still do some job shop work. In the recession in 2008, 2009, we found that our job shop stuff just disappeared. It was gone, and it was the bike stuff that got us through. And that was kind of a wake up, you know, how good the bike industry is for us, and how much it does for us. So it just kept on going. You know, we had our 40th anniversary last year. This year is the 41st year in business. You know, and I've been doing machine work since I was 13 years old. So it's kind of been a lifetime.
That's amazing.
It's amazing. And the thing is, I still come to work and I still love it. It's fun. It's making stuff is the best job I ever could have chosen for myself.
That's awesome. We had a question coming in from Mark. Go for it.
So my question is kind of, was the area that you grew up in, was there a lot of like blue collar industrial, or was it like just purely residential, or what was the kind of your exposure to industry as a kid?
Calvin's got it.
We had to unmute. Okay. Yeah. So I grew up in a place called Marin County, north of San Francisco.
Yeah, I'm familiar with it.
Okay. So not a lot of industry there. There was shipbuilding in World War II. Some stuff going on, but really it's a bedroom community of San Francisco.
What city were you in?
Corte Madera.
Okay.
Yeah. So the machine shop I got a job in did a lot of work for Hewlett Packard. So there's a lot of electronic stuff. So that was a spillover of the whole Silicon Valley thing. Silicon Valley is not just around Santa Clara; it goes all over the Bay Area. And Hewlett Packard had a facility in Santa Rosa, and that's where we got a lot of our work. So we did a lot of really detailed electronics work. So yeah, there really wasn't a whole lot of heavy industry or anything like that in Marin County. But what did happen in Marin County, and I was, all along as a bike nerd, in the late 70s, early 80s, the whole mountain bike thing was taking off in Marin County. And being a bike guy, I knew people who were also doing bike stuff. And the question was always like, hey, you started a machine shop. I got a bike. I want to make this thing, whatever this thing was they wanted to make on their bike. And it's like, can you do this? And I was like, yeah, I can do that. So I did a lot of bicycle machine work or bicycle related machine work. And like I said, I didn't intend to get in, specifically do bicycle stuff. It was a job shop, but the jobs that kept coming in were bicycle related. And that was just a really natural progression.
So you're getting up on TAM?
Oh yeah. Yeah. The house, the house I grew up in, I could ride at the top of Mount Tam, and only cross one paved road.
Nice.
Yeah.
Wow, that's cool.
Bunch of old photos.
You're in some of you're not in that one, right?
No, but the 10-year anniversary one, I'm in that one.
Yeah. I just came into bicycling from just kind of trying to learn mechanics, and then I also love riding and stuff. And I will tell you, you know this already, but I'm just talking to the audience in general. If you dive into the history of mountain biking and you dive into how the bikes are made, you really find incredible people. They have great trade shows. There's a show in Philly that has a mixture of consumer and also trade. I guess it's the Philly Bike Show. Is that Expo, right? The Philly Bike Expo. And then there's also the one that travels around, the Handmade Bike Show. That one's incredible, and I've seen you at that one. And so people that get into this machining and into bikes and welding, they take the bike seriously. It's really incredible. I remember meeting you at one of these events. Pretty cool. Do you still go to the events like this?
Yeah, I mean, I'm retiring this year. I don't know if we made that clear at the beginning of this podcast, which is why Calvin is here. I've been going to these events for a long time, and now Calvin has taken over, and Calvin will be taking the show to the Philly Bike Expo coming up in March.
Yeah, we have a couple shows this year. Philly Bike Expo is one. The Made Show in Portland, that's a new one, which I see taking the place of NABS going forward, because that hasn't happened for a couple of years, and it doesn't seem like it's ever going to happen again, which is unfortunate, because I remember as a child driving to Sacramento or wherever it was, if it was close by, and seeing all the cool bikes and exploring and just having a really good time. But it looks like Made can fill that spot, and hopefully going forward, more bicycle expos will continue to pop up. I mean, it's great for the industry, and there's also a lot of worldwide expositions. It's just that those are maybe a little more geared towards mass production, and we really, as many parts as we're making, we don't fall into the category of mass production. So
right, and there's a show in England that is kind of on the same par as a handmade show, and that's been a really good one for us too. There's a lot of custom bike manufacturing in England and all over Europe.
Nice. So yes, the main reason for the show tonight, besides to get to know you guys more and discuss bicycling and machining, is that you guys made a big announcement that Mark is retiring and passing the torch to his son Calvin. And Calvin, that's an amazing thing. We're excited for you as the shop teachers. I think I can speak for all the shop teachers. And so we want to know about this transition. But this is a good time to segue over to Calvin. Calvin, I think Peter's got a question for you. Peter, you want to take the question for Calvin?
Jenny.
Oh, well, Jenny's got a question. I'm sorry. Let's go to
I
Jenny first.
do. Okay, it's a two-part question, and either Mark or Calvin can answer it. And I'm sorry, I'm a big materials geek, and so, but I'm very new. I haven't done much bike manufacturing at all. So the two questions are: do you ever work with magnesium? Because I know like sometimes the forks and the frames stuff can be made out of magnesium. And then my second question is, and this is going to age me a little, but I think Mark might remember this. If you remember MacGyver, at one point, the old show MacGyver, he shaved off a magnesium frame and made like a flare or a thermomite flare, I believe. Is that possible? It's always baffled me, and you can Google it, and some people say yes, some people say no. And I have done magnesium machining before, but I know you have to have special, fire precautions and stuff into place. So I'll take it, let you take it away.
Okay, guys, unmute.
Yep. So yes, we have machined with magnesium before. Recently, at least in my time at Paragon, I've never seen us machine it. But I did actually put a bunch in a box and gave it to our scrap guy recently. So there is a history of it. And you're definitely right that magnesium is very flammable, very reactive, which is, I think, one of the reasons why we don't use it very often. But something that a lot of people may not know is that titanium is actually almost as flammable, I think, or at least
I've started titanium fires.
Yeah, and funny story with that. So we saw up these giant, like 3-inch thick and 4 by 8 feet long billets of 6.4 titanium, and we pass it through our vertical bandsaw. And my dad has a really cool setup where he actually attaches a chain to our manual lathe and uses the manual lathe to pull the chunk of material through the bandsaw. And he uses kind of a lever, right, to a pulley to really torque on it. So he was sawing that up one day with one of our employees, and the employee had walked away for a minute because, when you're in the middle of a cut, it takes like an hour. And so I'm on a mill, and I look over and I start to see like sparks flying and like smoke coming out of the saw. And I knew it right when I saw it. I was like, oh, there were wood chips in the saw, and someone didn't clean it out well enough. And sure enough, we'd been sawing the titanium, and I think we had run out of coolant too. It was just the perfect storm, and we had to sprint over and grab the fire extinguisher. And luckily, I think that time we didn't have to fire the extinguisher, but it gets your heart rate up pretty high when you see that going on.
Yeah, so it'll definitely light up. And to answer your question about magnesium, I never saw that MacGyver episode, but yes, I'm familiar with the show. Yeah, if you had enough magnesium shavings, it lights up just great. And it's it can be kind of fun to take a little piece of magnesium on a camping trip and sneak it in the fire when no one's looking.
Yeah.
And titanium is not as reactive, but quite reactive.
And is it sodium or magnesium that you can put in water?
Sodium.
Okay. Now that's another great way to start a fire is you get some pure sodium, chuck it in some water. Don't do this at home, kids, but there's some really cool videos and some cool history behind how sodium was actually used to do many things.
Interesting. I'm going through your Instagram. I'm gonna try and find. I know I've seen that pulley setup before, so I'm looking for it. But I think what we could do now is go to the big question for Calvin, and I think Peter's going to take that question. Go for it.
So, Calvin, have you had shop class growing up?
No.
Well, that's a definitive answer.
No, unfortunately, I did not. At my high school, I think we may have had some sort of woodworking class by the time I graduated, but nothing like, so I went to the same high school as my dad, Redwood High School in Larkspur, in Marin. And yeah, basically what he's told me about Redwood, it must be a very different place now, because there wasn't a single manual or CNC machine anywhere on that campus. But my dad was talking about teachers. I think I've been very lucky to have one of the best teachers in the world in my dad, and some other really great teachers in our employees. So though I never had a traditional machine shop experience where it was, you get your foot in the door and you start on manual and you work your way up, I was kind of thrown into it a little bit more. Put on machines almost immediately, and I got to press buttons. And at the time, I really didn't appreciate it, which is funny looking back on it. I think it was something that I didn't really understand, and I wasn't doing a ton of critical thinking at the time. I was loading parts, unloading them, maybe QCing them, if I was lucky. Otherwise, I was sawing or doing busy work. But that's part of a machine shop, and I've come to really enjoy that stuff because I'm a perfectionist and I try to look for little ways to improve every process, even if it's as simple as sweeping the floor. But yeah, I couldn't be where I am today without my dad. So in a way, I did have a shop class growing up.
Yeah, it's funny, of course. Yeah, the irony is that even though I'm a shop teacher and I have the Shop Class podcast community going, the irony is that I did not have shop class growing up either. But you do find a way, and in your case, you pretty much grew up inside the CNC machine, as evidenced from this photo. But pretty amazing, situation, and you've definitely evolved. And so now, maybe we could talk about the transition about to happen. You want to tell us a little info about the kind of what's going to happen and the story of the transition?
Yeah. We can talk about that. I guess maybe the best place to start would be kind of on why my dad is transitioning out of the business.
Yeah. So I've been doing this a long time, and as much as I enjoy it, there are some other things I'd like to do and explore other parts of the world. That's a great photo. And at some point you need to retire. It's like, I could keep doing this longer, but I've got a really competent guy here who wants to take over the business. We got great employees. So it's just it's a basic retirement plan. And as we got into it, the sort of concept that I was going to eventually retire, was always kind of in the back of my mind. And I think 5 years ago, we actually wrote up a little schedule of how I was going to back out of the shop, which none of it ever didn't happen. But the hardest part about doing the transition, I think, is doing all the formal stuff you have to do. You've got to, to figure out, what the payment schedule is going to be, and what is, how is the not the economic part, financial. How's the financial part of it going to work? That's what I'm trying to say. And that took a while to figure that out. And then there's taxes, and then there's legal documents, and then there's getting Calvin into the corporation as the president and me out of there. So it's a definite process. And also in that whole process, my wife, Donna, Calvin's mom, has probably done 10 times more work than either of us have done on the transition. I really have to shout out to her that she really made it happen. So thank you to Donna.
Yeah, and on that note, Donna, my mom, goes unrecognized. She has to deal with customers talking to her about how we messed up their order or if something was wrong. And a lot of people don't realize how large of a role that she takes on here at Paragon. She runs the web store. She's historically taken on pricing, customer relations, and any paperwork and any legal or banking or just all the stuff that is so important to a business running. So yeah, a big shout out to her. It's a thankless job what she does.
Got it. Yeah, I mean, it's a pretty amazing thing you got going. So in the current situation, you're doing jobs and supporting the bicycle industry. Hope I don't jump the gun and ask you too many questions, but is there any like my dad had a bakery, and if I transitioned during his retirement, I had some ideas. And so I was like, okay, I would do this, I would do that. Is there anything new on the table that you want to talk about tonight? Any new ideas?
Yeah, I think a lot of my ideas have been internal to start out, and they haven't necessarily been like huge sweeping changes, but they've been small improvements on existing systems. A couple of examples of that is tool and material organization. I've really taken the initiative to make sure that everything in the shop is labeled and organized in a manner that basically any novice machine operator or shop assistant can come in and at least have a basic idea of where everything is. Because there was this one day where I'd spent like 45 minutes looking for one or two tools, and I got really frustrated. And I said, there has to be a better way to track these things. And lucky for me, a lot of that organization was already there. It was just, it kind of needed that last little push, I think. And I'm sure in 40 years, my child will look at me and saying, wow, this system is like, this doesn't make any sense. We need to change this. But it worked.
Calvin, I'll tell you something funny. I put in the credit card machine at my dad's business. And so, like he had this great business going, and my grandfather started it. We had this bakery in New York, but he never made the transition into credit cards. And to me, it was like super obvious. And he's looking at me like I'm nuts. And so, I went to Radio Shack and I grabbed the wire and a splitter, because, it's all phone line back then. And I stapled it to the staircase, and I went up the stairs and over the door jamb and all that stuff. And I got it out there, and he didn't even want to do it. I got the bank on the phone, and all he had to do was give him the code, and he finally gave him the code. And so it's those little things that make those little changes, but it's like there is a next step, So that's pretty funny. So you're like, okay, well, I want to label everything. Seems obvious, but not that it wasn't labeled, but now you want some sort of extra filing system. I totally agree with that. When I have this situation here with new students, I try and do these things called self-guided tours. And so, we probably could learn a lot from your organization system, because when you're training a new employee, or let's say if someone who hasn't been there for 10 years, they're only there for a couple of years, they might not know where everything is. And then it does slow things down, and when I get new students, they don't know how to use the drill press. And so I'm like, okay, man, I can't teach the drill press. This is the year 19. So what I do is I have a students, we have a book and a set pre-game, a set of materials and clamps, and they just walk through the tour. But the tour was, took feedback from new people. If a person can't follow the tour, it's the tour guide's fault. So we have the person who wrote it fix it. And so it's kind of the self-guided tour. It's challenging. And so I'm sure you have something similar. You have a machine and all the tools and the material. And if someone can't find something, that is the fault of the people who set it up, So and is there anything else that you're planning on doing?
Yeah. We're really going all in on tracking what materials our tools were used in, because you can't use a tool in steel and then immediately use it for titanium. That tool is just going to break generally, especially if it's an end mill. So really just separating our tools out. But I think what you also might be getting at here is, well, what broader changes or additions am I going to make to the business as a whole that people on the outside would be seeing? I think a really cool one that I'd like to hand over to my dad to talk about is our new dropout. that we're going to be releasing soon. It's kind of the first of its kind for us.
Yeah.
Isn't it?
So are we allowed to just do shameless self-promotion here?
100%.
Okay, good. So part of the whole thing about running this shop is bicycles evolve all the time. There's new stuff coming up daily almost. And so what we need to do is keep on top of what's happening in the bike industry. And so one of the things that came up 5 years ago or so, maybe longer, is a thing called a flat mount brake. It's a brake caliper for a disc brake. It's just a different way to mount it. But we had to address that. And then the other thing that came up recently is a component company called SRAM came up with a different type of derailleur mounting. The derailleur is this thing that shifts your chain on your sprocket so you can change your gears. So the combination of these two things really changed the way Dropout's design, or our design. And let's see if I can, let's see, where's, that's it right there. Yeah, so that's it right there. So this is the left side, and this incorporates all the stuff on SRAM's new derailleur standard and the flat mount standard. So it's the Dropout integrated with the brake mount. And the idea here is that it's a whole lot less work for the frame builder to do. The frame builder doesn't have to weld the brake mount on. It's integrated directly into the whole Dropout assembly. And this is just kind of typical of what we have to do to stay on top of an evolving, dynamic business. You've got to come up with new products all the time. Yeah, and here's some stuff. So yeah, so this is a flat mount. This is on the front, and it's just you know, it's the same thing. It's a brake caliper, but the mounting system has changed. Now, why would you change the mounting system? So you can sell more bikes, I guess. I don't know. But yeah, and that's a pretty typical thing that people outside or people that aren't internal to the business are going to see us doing this kind of work. And this is why we do go to the trade shows, to show off this new stuff, and why we have the website and our Instagram to get the word out there and let people know what we're doing. And this particular part is titanium. We have a similar option in steel.
Now we got some questions coming in, and then I want to do a follow-up on this. Let me just get to the questions here. Hold on. Okay, yeah, Mark's got a question.
Do you guys ever think about moving into custom motorcycle parts?
That is something that I have thought about, and I'm sure my dad has also thought about. I think motorcycles are cool. I think they're a lot more different from bicycles than people may think just looking at them. They're also a lot bigger, so the machinery you may need for a motorcycle may not match the machinery needed to make bicycle components, not to mention the size of the tools and things like that. Does the company yeah, oh sorry, go ahead.
Oh, so one thing I was gonna say, like, if there's a company that you want to look at, check out Cognito Moto. They do a bunch of stuff. They kind of specialize in bikes that are more in the cafe style, or they're adapting an old bike and you want to use a new front suspension, so the triple tree will be a different piece. And they do some great work. They do, you know, beautiful products, but it's about the same. Probably it's a little bit bigger in scale, a little bit beefier, but really nice, clean design.
Oh, incognito. Sorry. Pretty cool. Yeah. Maybe send me a link for that, Mark.
All right, I will.
Okay. So I got to. Oh, go ahead, Mark.
Oh, sorry, Ron. I wanted to follow up on that. So one of the reasons why we can do so well in the bike industry is that I'm a complete bike enthusiast, and almost all of our employees are just, you know, foaming at the mouth bike enthusiasts. So we understand bikes. We know what bikes are. I mean, of course, I understand what motorcycles are, but I don't have the depth of knowledge in the motorcycle field that I do in the bicycle field. And because we do have that depth of knowledge in the bicycle field, we're designing our own parts from scratch, and we're actually in a couple cases we've actually pushed the entire bike industry in a couple directions. That lack of knowledge in the motorcycle manufacturing or motorcycle industry, I wouldn't be confident starting our own product line. But if someone had a part they wanted made, if it was simply a job shop kind of work, if you had a caliper mount that needed to be made and you had a good drawing or a CAD model, yeah, we could make that. That's not an issue at all.
Yeah, and that does remind me of something that my dad told me a long time ago that stuck with me. Is he said, the great thing about taking over this business, it's not that we manufacture bicycle components, but we are a machine shop, a manufacturing business, which means you can take it in any direction you want. And that was probably what really made my decision final that I wanted to take over, was the thought that, you know what, I may not be as passionate about bikes as my dad or some of the other employees here, but that's okay, because I just need to, at the very least, get my foot in the door and keep doing this for a while. And if I really feel that bicycles are not for me, I can take the company in a different direction. But I'm glad to say that bicycles have become much more exciting for me, and I really enjoy the process of designing and manufacturing the components.
There's I need to get your contact info. There's a couple of people I need to get in contact with.
Nice.
One guy's a designer for BMW, and then the other guy is a custom builder out of Kentucky.
Super cool. Super cool. Just out of curiosity, how big is the custom frame world? I mean, how many builders are there? Is it just maybe like 100, or is it thousands? Like, how many people do you think, unique individuals, you think there are?
It's thousands. I was actually having a conversation today with somebody, and we were talking about kind of the distribution of our customer base. And I think traditionally a lot of companies, 80% of your revenue is generated with maybe 20% of your customers. So you have a very small number of people buying most of your products. Whereas I would say we're actually the opposite, where probably 80% of our business comes from, hobby builders or people manufacturing 5 to 10 bikes a year. And doing it as a part-time job. We really, the reason we're able to survive and thrive is because people are so passionate about it, that there's thousands. I mean, I would say there's probably tens of thousands of people manufacturing bicycles in the United States every year, though the number of people who are actually trying to make a profit and not just mess around and have a good time, I'm not sure about that. But it is, as far as the number of people go, actually a pretty large industry. It's when you get into production, custom frame production, that you really see that the number of people actually doing that, and not just doing it, but doing it successfully, that drops off precipitously.
Okay, cool. So on the topic of research and development, coming up with new ideas, I got a question about your process. So, for instance, just a little insight into being a shop teacher and having innovation in the shop. One of the biggest things that a shop teacher struggles with is teaching strength to weight ratio. Getting something to be strong but also lightweight. What happens is it comes down to my opinion versus the student and what they're working on. And I used to have those conversations, but they're very frustrating conversations, because students think that it becomes like your opinion. I mean, sure it is, but what's happening is that it's like a battle of will, and a teenager, they'll always win. There's just no chance. So yeah, I'll get my butt kicked when it comes to willpower with a teenager. But anyway, so I don't want to battle them on it. So maybe 10% would trust my advice and shave down the parts and make them better. But the other 90% are just going to go at like a really bad overbuilt design. And Duke is kind of nodding his head, right? You know what I'm talking about, right?
They'll make it harder for themselves when they think they're doing it the easy way.
It's brutal.
instead of taking our advice and doing it the right way.
Exactly.
So do you let them make their own mistakes though?
Heck yeah.
Okay, so 100% I do, but I finally came up with a way to do it, which is that I use disposable, materials to start out with, and we have competition. So, for instance, let's say you build a flashlight, and you have to make the flashlight survive, like being thrown down the stairs. It has to survive a 50-pound crush. No less than 1 inch. It has to be vibrated. I use a tumbler to vibrate it. Yep, it's a great tool for lots of different stuff. And then it has to have flip on, and then it has to certain amount of lumens. Anyway, it goes through a bunch of tests, and when it's done, it has to weigh less than the other guys. So it's a competition. So less weight means less material, but it still has to survive all these things. So my question to you guys, that's my process of getting newbies to be good engineers, is that they look at it, it's a competition. Now, you're in competition with the bicycle industry, and so you naturally have these things and you have experience. But do you have a design process? How do you make great parts? Is there a process to it that you've already refined, or is it literally like you wake up and you're like, wait, let me try this? So you want to give some insight into your R&D?
Sure. One of the great things about bicycles is they've been around for 120 years by now or more. So there's a lot of empirical knowledge in the bike world. Everybody knows how big a steel frame tube has to be for a particular weight rider. I mean, that's been solved a century ago empirically. So we do have this great background of knowledge that we can work from. It gets a lot different when we get into different materials, into aluminum frames and carbon fiber frames and titanium, because the properties of the material are quite a bit different. But that said, our products that we've been making, there's a certain amount of overbuilding in there for sure for insurance. We don't know what our parts are going on, so we've got to assume that the parts are going to be used by a 250-pound rider who likes to jump off loading docks. So unfortunately, that can lead to some heavier parts. We also have some parts that are quite a bit lighter weight, and people ask me, I weigh 250 pounds. Should I use this part? And I'll direct them towards a part that's quite a bit more robust. So we do have a choice of parts there. When we design a part from scratch, like the Dropout we just showed a little while ago, again, we're doing a lot of this stuff empirically. We have similar parts that we've had on the market for quite a long time, and we know they don't fail. And when they never fail, that's a good sign. You can start taking some material away. On the other hand, if it's in the ballpark for weight and it never fails, I'm not going to mess with success. I don't actually have a formal engineering background, but strength of materials is huge. That's just that's where it all starts. You start playing around with looking at charts of materials, and okay, what's the tensile strength of 1018 compared to 4130, and you get an idea of how close you can shave some of this stuff down if you know what your existing part as it is. Calvin actually has a mechanical engineering degree, but I'm not sure that we necessarily have the tools where you can take full advantage of that. We don't have the testing equipment to really be objective about what our parts are doing.
Yeah, hypothetically, I think we could do some virtual stress testing. That's something that we learned in college how to do using SolidWorks. And it's not that hard, but in theory, it's not that hard. But then you have to say, well, what sort of forces are going to be exerted on this part? And how does this part fit into the entire assembly? And also, do I pick, 1,000 newtons of force or 5,000? And then there's questions like, well, what's my factor of safety, which is basically, a number that you multiply your final result by to get your final number, saying, okay, I want it to be 50 times stronger than it needs to be. a great example of this is elevators. I think the factor of safety on them is 20 times. So when you see the weight limit is 5,000, the weight limit's actually 100,000, because they know that some goofball is going to try to fit a bunch more weight in there. So it's things like that where you do have to over design to some extent. We could make the quote unquote ideal dropout or ideal bottom bracket shell that could work in one specific scenario for like a light rider on a flat road, and tell people that that's the only thing you should use it for. But the fact is people won't respect that, and they could crash, something could break, they get hurt. So you are kind of stuck in a corner of designing parts heavier than you want them to be. But
right, because we are designing for kind of the worst case scenario, because we are selling our parts to anybody who's going to build any kind of bike. So there's only so much we can do about really trimming the weight down to the minimum.
Nice. Jenny, go ahead. You got a question?
Yeah, actually, I think you were getting to it, but I'm curious, what kind, because you're using functional parts that are going to be at a bike that anybody can buy and assemble themselves, what does the liability for that look like? I mean, that's a whole new consideration, right? For a functional part versus maybe something that's a little more aesthetic. So do you have to have like contracts in place, or, I mean, what does that look like from a business owner's standpoint?
Well, so to start with, we have liability insurance. And, you know, knock on wood, it's never been tested. That's never been an issue. So, so liability insurance is kind of, you know, I hope it's a defense. I don't know if it's ever going to prove out to be valuable or not. But that's then, you know, getting back to what you're saying, as a business, how do we address that?
yeah, you know, it is a tricky question, and I'll say that luckily we have not had many issues where a part has just completely malfunctioned and we've had to recall an entire product line. I think it maybe happened once or twice where there was some issue, and it might have just been a dimensional thing or something like that. But the bottom line is we're very careful with the way we design things, and we tend to over design when we can, not to the extent of just making it, you know, a 5-pound dropout, but you know, we really just try to never get there. And it's worked so far. A lot of the time we will have people reach out to us, say, hey, you know, your dropout failed or this or that. And a lot of the times it's not necessarily actually the dropout that broke, but the weld potentially. We see that a lot where, you know, I think it's more likely that a weld will fail before one of our parts. We've seen that historically. So, I mean, we don't have a ton of experience, luckily, with our parts failing, but it can happen. And I think a lot of people are reasonable in that, you know, if you do a backflip off a 50-foot cliff and land on your bike, like, it's probably going to break, you know? So there's also this balance of, okay, at what point did I put my bike in a situation that maybe it wasn't designed to handle? Because we don't design for the worst case going off a cliff.
It's just when you do have the end customer doing the work on that kind of stuff, you always wonder, like, are they going to be pushing that envelope beyond what this part can do? So,
you know, it seems like you guys are not just, you know, obviously not just machining and not just making parts, but you're part of a biking community and part of a research and development community. You know, I recently watched the documentary about Jake Burton and, you know, Dear Rider, which is incredible. And they had to go through so many iterations. And one of the things he said was that he, his business really took off when he looked at it as like a rising tide and lifts all boats, and started helping everyone in the industry by supporting competitions and riders, and you know, and using the lawyers to, you know, because they wouldn't let the snowboarders at some of the resorts, which is still the case in some, you know. And so you know, you want to just talk about the industry as a whole, and how you guys have supported the the bikers and stuff like that. Oh yeah.
Oh, yep. Hang on a second.
There you go.
Oh, there we go.
Sorry, I had to let the dog out.
Yeah.
She was
So
scratching.
yeah, sorry. I was distracted here. Can you give me a 5-second recap of that?
Oh yeah, no problem. Yeah. So basically, some of the things that have happened for businesses that are really successful is that they become part of the community. So I know my grandparents and my dad's bakery really was like a community stable, like it was a place for people to come and talk about the old country or whatever. And before Starbucks and in all the places you could hang out in New York, this was, my dad's bakery was like the spot where all the community would go and get their baked goods and stuff. And for you guys, and for Burton, he really kind of brought a sport, and it wasn't just selling boards. Although I will tell you, I have a Burton board that's 15 years old, and man, that thing has no cracks in it, and I beat the crap out of it. It's unbelievable. So can you just speak to some of the community involvement that you've had over the years with the bike industry?
Sure. Let me take that. Yeah. So as far as the community goes, on a really basic level, it just sort of inadvertently popped up as Paragon for a long time was the only supplier of titanium frame building components. So if you were building a titanium frame, you either made all your parts yourself or you came to us. And so that really developed this titanium frame building community, and word of mouth got around, and it really was a community because people were helping each other. People were handing out information. For a long time, how to actually weld titanium was a closely guarded secret. And once the secret got out, everybody figured out it's not that hard. You have to be careful, but it's not hard. So yeah, one frame builder once told me, if you ever go out of business, you're going to put a whole generation of frame builders out of business. And that's, again, one of the reasons why I'm glad Calvin has taken over this. So yeah, the bicycle building community, I think Paragon has managed to lift up the whole community and come up with some innovative products, and really allowed people to either do this as a hobby or do it professionally that they may not have been able to do. And the other thing that goes along with that is the rise of the internet. Everybody can look on the internet and see anything and buy anything anytime they want.
Yeah. And I just want to state that I have no intention of letting the custom frame building industry die. I think it's an awesome community, and as long as people want to build bikes, Paragon will be here to supply the frame components that they need. Now, as far as community goes, I think there's been a few things we've tried to do to keep the community thriving. One is donate to bicycle coalitions or parks in the Bay Area, things like that. We're not donating millions of dollars, but we're chipping in and trying to do our part to keep the bicycle world going. And we pretty much every year that I can remember, or at least recently, we've supplied builders who go to shows with discounted or free parts. I think the Philly Bike Expo has a scholarship this year where a few, like 4 builders maybe, get to build their own bike and then show it off. And so we give them all the components for free that they need as long as it goes on the bike. And in some ways it's not selfless because people see our components, and so it's an advertising opportunity, but it does also allow some new builders who may not have had the opportunity to build with some of our more expensive components. It allows them to pick what they want and really do what they want to do and explore. And I mean, that is such an important part of an artisan industry, is being able to be creative and make it look how you want it to. So yeah, we try to make sure that anyone who wants to do this can and has the opportunity.
Nice. And I can attest to that. Mark's always been real cool with me, and whenever I had questions, able to answer them in depth. I was always interested in the CNC, and now we have Jenny helping out as well. And I think that you guys would be a great influence on the shop teachers. So that's a segue into one of the last questions, which is what would you want the shop teachers to add? Like, what do you wish you had in shop class? Now, I will say, I don't think that teaching is the filling of a bucket, which is kind of like the old saying. It's really the light of a fire. And it's really funny, if you go back to the original story that Mark said, is that he kind of lit off this rocket cannon thing, and that's the light of the fire. He's like, how'd you make this? So really it's the lighting of a fire. And I'm not looking to teach kids everything. I do want to just get them excited and then fuel the fire. But what are some of the things that you think the shop teachers should add? And keep in mind that they might not have a machine shop, but they might. Some people might have leftover equipment. I know we had a lathe here from the 40s, and the milling machine was gone when I got here, because in the 90s they wiped pretty much all the shops out. And we just don't want that to happen twice, because it took a long time to build this back up. And I'm sure you've had your share of growing pains. And so imagine in a school with the bureaucracies, it's very difficult. So what things would you want to add to the shop classes? What do you think?
Yeah, I think generally speaking, programming and coding, number one. I mean, every single job today and going forward is going to be based around some sort of computer-oriented software or system. It's just unavoidable. And every single one of my friends in college, regardless of whether they're an engineer, a math major studying poli-sci or economics, had to know how to code, because it's such a powerful tool. And it may not seem directly correlated, machine shop class and programming, especially if you're using manual machines, but there are computer programs that can allow you to create really intricate designs and teach you how to do these things. I use coding to optimize my programs and run loops so that I don't have to write 500 lines of code. I can just do 5 lines and just program it to add, a pass over and over. So, I mean, it's incredible what you can do with that technology. And the second big thing I would say is 3D printing. It's not apples to apples, but I would say 3D printing is to CNC machining as CNC was to manual when that was released. Though 3D printing has much different applications than either manual or CNC machining. But again, I mean, if you think that 3D printing is not going to take over in at least some aspects, then you don't know anything about 3D printing.
And to go back to what Calvin said, 3D printing is all about coding. If you can't use the software, you can't 3D print.
Nice.
I think a lot of it now is with the slicing software. There's the part where you're drawing the part and you have to draw it correctly. That goes in hand with the slicing software as well, because you can maybe draw the certain parts to cheat having to make to build up the 3D print at different parts.
Yeah, and Duke's doing 3D printing in the middle school, which is pretty amazing. Duke, what kind of stuff do you do with the students?
They're just drawing them on something simple as the Tinkercad, but they all want to make the things with like long arms. I tell them it's like a tube of toothpaste. Once you get past the toothbrush, if there's no supports, it's just going to droop right to the ground.
Yeah.
So that's what I was talking about, the slicing software. You don't want to print with too many supports, because sometimes it sticks too much and you have trouble pulling them out. So when you're drawing it, you have to be creative and like maybe make it at a 45-degree angle or have more fill, which you don't really need, but that eliminates the need to print some supports.
Got it. Got it. And just to go around, Tori, you're in buildings and trades. I've seen some 3D printed houses out there. What's going on? What do you think of all that?
There are, yeah, there's some concrete 3D printed homes that are available too. Absolutely. Yeah, it's pretty cool technology. Yep.
Also, you know, on the topic of construction, there's some modular homes, and those are going to use CNC machines and assembly machines. Are you using any modular pieces of construction?
We have in certain circumstances, absolutely, yeah.
What would be an example? Is it the what is that called? The rafter and the piece, like the triangle looking piece?
Yeah, the trusses and stuff. Yep, absolutely.
Okay, and they ship it in, and then you can just install it, and you don't have to make them on site.
Absolutely.
Okay, interesting. Very cool. Peter, is there anything? What do you think about 3D printing as far as a teaching tool? What do you think about that?
Additive manufacturing is a really good way to go. It just, yeah, it's coding skills, like you're saying. You produce your path or make the form, send it to the interpreting device, transmit it, and let it go. Yeah, 3D printing is the best. I've done that in school, and it's a great experience. Great, and 3D printing is with concrete. You can use all sorts of different materials, from plastics to metals. You can melt the metal and it'll cool and congeal again. And concrete's the other one. Yeah, it's good. 3D printing is a real good talent.
And let me go back to Mark and Calvin. What about small business owning and running? Is there something that the shop teachers could teach as far as that goes?
Yeah. I think it's a labor of love to some degree to run a small business, because it is always going to be harder than running a larger business. It's harder to bounce back from recessions and things. I think that it's super important to perfect the process. And by that, I mean, if you're going to be trying to do this as a career, finding ways to make money, because if you're not able to support yourself, then you can't support other people. And there's finding this balance of, okay, I want to make this accessible to everyone by charging the least amount that I can, but if we can't survive, then we can't teach anybody else. So I would say, you know, don't sell yourself short, you know your value and advocate for yourself, I think.
Yeah, as far as shop teachers, you know, telling people about business stuff that might be getting a little bit off topic, but I think you should definitely bring it up, because there are a lot of people who are successfully self-employed, not necessarily doing machine work, doing all kinds of stuff. I was fearless about starting my own business because my father had his own business, and that was just normal when I was growing up. So my dad was self-employed, and I was like, well, wait a minute, you mean not everybody is self-employed? You know, so it was a really easy transition for me to make. So definitely get kids to know that it's an option. And again, like you said, light the fire, and then they can go and take some business classes, the math classes, the other classes they need to have the skills to run their own business.
Nice. Okay, well, it's getting a bit late, and I think, you know, we've covered a lot of this topic tonight, and yeah, I really appreciate it. If there's any last questions, we'll kind of wrap it up. Peter, go for it. What do you got?
Just wondering, from Mark and Calvin, does the company hold any patents for special parts?
Yeah, I can answer that.
You go ahead.
Yes, company holds one patent for a type of dropout. One of the things that's happening in the evolution of bicycles, getting away from chains and running with belt drives. And belt drives have a different, a tighter tension than a chain. And so what I designed and patented was a dropout that had a quick release mechanism for tensioning the belt. So when you get a flat tire, you can quickly untension the belt, fix your flat, put the wheel back in, and with a flip of a lever, your belt tension is right back to where it was. I rode a bike with that system on it for years and years, and it worked flawlessly for me.
It was cool.
Yeah, it was cool. The transition into the real world, there are a lot of small parts, a lot of what people said were really fussy adjustments. So we actually dropped that line of dropouts because and with all those little tiny parts, it was really expensive. So I felt it was a success for me personally, but a lot of consumers had a hard time with it. So I'm glad I went through the patent process. I learned a lot through that. I think I may have been a little premature with that particular product. And as far as patents go in general, we don't have any other. We have a lot of intellectual property in the designs of our parts, but we actually put them out there. We put step files on the website for people to go ahead and use as they see fit, and a certain amount of that, parts get duplicated in other shops, and we don't get any credit for that, unfortunately. But again, it's kind of what the community that Ron was talking to. Our sliding dropouts we've been doing that since 2007. Other people are making interchangeable components that go with that, and I think ultimately in the end, maybe we're not making any money from that, but it's enhanced the whole bike industry as a whole. People have parts that are interchangeable. They can buy them from multiple sources. They have a lot of different price points they can choose. And I like to think we're the original and the best on a lot of this stuff.
Nice.
Yeah.
It's interesting. What is that? McMaster Carr gives you, I know they're not innovating, they're just selling you hardware, but they give you the CAD, and then you can use the CAD to kind of see if it fits, and that is a nice thing that they do. Obviously, you can then buy the part from them or make it yourself because now you have the CAD file, but you'd have to then figure out how to make it. And like you said, if you guys have it all dialed in, and your creativity and innovation comes in making this stuff available at a reasonable price, then the person would just go with what you guys have. Is that a good description of giving out the CAD, but yet still supplying the part, right?
I think so. Yeah, that's a good description. It's also what's good for the bicycle community is inherently good for us, and I mean, I think we could have gone in two directions. One would be trying to hoard everything to ourselves, but what we've seen in the bicycle industry is when people try to really hold on to a standard and say this is mine, people just say, all right, I'm gonna go add a millimeter to that thing and make a new standard. And then so when nothing is standard, everything is. So it's not like it would really benefit us to say you can't make this part, you can't use this part unless you pay us a lot of money and you get our permission. It doesn't make sense in 99% of scenarios for me, given the state of the bike world.
Yeah, when components are proprietary, people don't adopt them. They try and find an open source thing that is universal.
That's a good observation. Yeah. Because why wouldn't they just try and make it themselves? And then if they see more about it through open source, then maybe they'll go with the supplier that got them there, So it's kind of a sales pitch in a way, and community. Pretty cool. So, all right. Well, I really appreciate all the time you guys gave us. And, I hope this serves as some inspiration for other shop teachers. And it was great seeing everybody here. We had Corey in the construction, building, and trades, and we also had Jenny. Jenny, you got to keep us in the loop on all the cool stuff you're doing.
I will.
Jenny, have you made any bicycle parts? I should have asked that earlier.
No, I haven't. I mean, I guess there's always a possibility. It's just been, I've been so involved in the mold making world, but I'm fascinated. And I did want to say, when we were talking about the 3D printing part, I remember this was 10, 12 years ago. I was at a company called Scientific Molding Corporation. And I remember sending out a part to be done on a sintering machine, which is the 3D printed metal. And, people are like, oh, it's going to replace tool makers. And everybody was panicked. And what it ended up doing was augmenting it. And I don't know if you've done much with molds, but if you've ever run a gun drill, have you ran a gun drill before?
I haven't.
So-
I don't know what that is.
So mold base, they're usually big and you have to either cool them or heat them depending on whether you're doing plastics or silicone. Silicone usually heat the mold to like 400 to 700 degrees Fahrenheit with thermocouples. Thermoplastic, you cool the mold by running cold air underneath the cavity core block. Well, back in the day, the only way to get those water lines in, and they have to be underneath the cavity or the core, you're drilling from one end, then plugging it. You have to then cross drill. So you have holes coming in from all four sides. Well, I remember being floored because we had sent it out and sintering was still relatively new, but we sent out a core block. And for anyone who doesn't know, a core block's kind of the male part. You have your cavity where, you have the depressed area and then you have the other part. It's called a core or a force, depending on who you talk to. But I remember that we had this detail sintered. So we had the core block sintered. You still had to finish machine it, but they made it so that as they were putting the layers together, they added the water lines so it could get closer to the surface. Do you know what I'm talking about? And I just remember thinking, this is amazing. We can get rid of the big, messy, oily, nasty gun drill because gun drills, you're drilling feet with this big, giant drill and you're pushing oil through it. And when you hit the end, and you're nodding because you probably know, you hit the end just right, all of a sudden oil everywhere. And I just remember like with 3D printing coming around, people were panicking, like we're all going to lose our jobs. And I'm thinking, I wasn't worried about losing my job because I'm like, look, someone's still going to do grinding and fitting. It's something that isn't going to be replicated by a machine at this juncture. But I just remember thinking 3D printing was the coolest thing to ever happen to machining because you can add all those internal details. So as you were talking about it, I'm like, yeah, spot on. Like the coding and everything, I think that's the future right there. So
That's awesome. Wow. Jenny, you know so much and it's great. We got to get more into it. So from my understanding of what you're talking about, it's just to have cooling lines go through the mold.
yeah, I've actually got a little baby mold here that I made when I was in trade school. And this one, it's super simple. So this was an eraser mold. I got a little turtle in there. So this would be the cavity. So you can see how deep that is. And then we got the core. And then you have an ejector system. Have you ever ordered your Happy Meal and the cheap little toys in there? They usually have those little round pieces. That's from an ejector pin. So the pins, and I'm not going to try to line it up because it's a really old mold, but these pins go through, and that's what ejects or pushes your part out once it's formed. But you'll see on both sides, I've got holes. And that's where the water lines go, and that cools everything off so it cures it. Silicone's reverse. Now, silicone goes in like a regular epoxy where you have an A and a B, but you keep both the A and B cold in this thing called a cold deck, and you shoot it through, and as soon as it hits the hot mold, it sets. So it's kind of the reverse. Different molds are different. You have magnesium molds, you have all these different setting styles. But yeah, so this is the block. You can kind of see the line around it. This is actually fit in there. You've probably seen on YouTube where people have like EDM stuff where they slip it in and it pops in really nice. Kind of like that vein, only I ground it. I'm just that good. But okay, maybe not. This was my trade school mold. But I do like to use it for an example when I'm explaining stuff to people because I can carry it around with me. But yeah, when you're thinking this is just a tiny little mud set mold. Now, when you think about like a real industrial mold, a lot of these are huge. We're talking thousands and thousands of pounds. And so this mold base could, I've done some where the mold base is probably, my goodness, probably an eighth of the size of this room. And, you have these big, giant ones. Well, you got to put all these holes in the base as well as the cavity. So, that's a lot of material to be running through the gun drill. And it's just nasty, time consuming. There are pig mats everywhere. You'd walk in the base department and you walked really carefully, otherwise you'd fall on your tuchus.
Man, this is the new GigaPress is like injection molding for aluminum on the cars. I mean, this is like, look, are these the pins you're talking about?
Oh, the ejector pins?
Yeah, these are the presses, but I'm sure they've got some crazy ejector pin situation.
Some of those molds have thousands of pins. It's just, if you get really complicated multi-cavity units, it's insane. It can take months to close to a year to build some of these molds, depending on
that's wild
how complicated it is.
Pretty cool. Well, we're gonna wrap it up right here. This is awesome. I really appreciate everybody coming in. Jenny's always bringing the fire, and Mark and Calvin, you guys are awesome. Thanks for doing this.
Yeah, I just want to say thank you, Ron, for hosting this, and thanks to all the other guests for being here. It's really interesting. I learned stuff. I always love learning things. And also, if any of you are ever in Northern California, there's an open-ended invitation. Come on by and visit us.
Yeah.
Oh, very cool.
Thank you so much.
Pick you up on that.
Okay. It's great to have this opportunity to get my voice out there and also learn from people and see what people are interested in and what other people are doing. So this was a really cool experience for me.
Awesome. And I could speak for the shop teachers. I know Mark has always been very open doors, and it takes questions and whatnot. And Calvin, we got your back. So if you need anything from the shop teachers, don't be afraid. Reach out. And I know some shop teachers in Southern California. I don't know any in Northern California yet, but we've definitely got your back, and we got a bunch of shop teachers throughout the whole country. So if you ever need anything, let us know. If you want to bounce ideas, we're here for you, man.
Community prototyping done. I'll give you my information.
Thank you. I appreciate that. And alternatively, if the teachers want bike parts, we provide them. I'm not going to say we can give everyone free parts, but for educators, I think we could definitely have a conversation about making it easier to acquire bicycle components, because it would be really cool for people to be able to weld with them. That might also be a part of shop class. I'm not sure, depending on the class, but so it goes both ways. I appreciate it.
I should say that Mark has sent me some head tubes and bottom brackets, stuff that was kind of, I guess, left over or whatever. And I was like, hey, do you have any rejected or damaged parts? Send them my way. And so we were ramping up towards that. We did make a miniature bicycle example, and we did some MIG and TIG welding, but then the pandemic hit and we switched projects and went up. But I do want to bring that back. We got the TIG welder fixed. That was broken for a while, and we have a bike stand in here. I always keep my bike park tool bike stand there, and we got all the bike tools in that one cabinet next to it. I don't know where I'm pointing, but anyway, yeah, we're always doing bicycles. That's a core piece to the curriculum. It's the best way to learn, because what I love about bikes is you have to fix them in front of a crowd, and it's right there, and it either works or it doesn't. There is no like, oh, maybe it works kind of. The deraillers like clicking. No clicking. Did it go into gear or not? So so it's pretty cool. And you can use old bikes to do stuff, and you can modify. So it's a great learning tool, mechanical parts. So cool. So maybe we'll restart that welding project, maybe possibly next year. Right now we have, I don't know. We got a lot of kids welding this time, but we'll see. You'll see how it goes. But I got to get kids on the TIG welder. That's the next thing. So that'll be pretty cool. So thank you so much. Anything anybody else wants to add? Duke, what do you got?
Yeah, Mark, enjoy retirement. 40 years, you deserved it.
40 years, you deserved it.
Yeah, I
appreciate that. Thank you.
Now, are you going to be straight out, or are you going to keep your toe in the water for a little while?
I'm transitioning out. I'm going down to 3 days a week, and then eventually fade out, but I will always be available for consultation or ideas or just hanging around the shop. I got a lot of projects I want to do.
Cool. Nice. Sounds good. All right. Well, we'll end it there, and I really appreciate it. Shop Class Podcast, very cool. The next podcast will be on location in New Jersey at, ironically, the New York Model Engineer Society. So it's basically trains. So toy trains, HO scale, Lionel O scale, and it's wild. There's like this whole building not far from here that's just all model trains, and they have a machine shop, and they do not use it. And they asked me to reach out. They said, our membership is dwindling. What should we do? I said, have the kids machine all the parts for the train. It's like super obvious. And then also another idea I thought of, I bought a little model train thing, believe it or not, for my girlfriend who's into trains. And we were putting food in it, and you could send it around the table to serve someone. So you could have like an adult night at one of these events. You could put drinks in it and stuff. I mean, I just think that model trains are fun. And so we're gonna next episode, we're gonna go on location at the New York Society of Model Engineers. So that's gonna be pretty cool. And we're gonna revive their machine shop. They've got like old machines. They got like a Burke, which is like an old California miniature mill, and they also got a lathe in there and whatnot. So it'll be fun. All right.
I got two kids. I got two kids in my club that are like obsessed with trains. They know everything about it, like everything. I got one of those old like Stirling motors, those steam engines that every shop teacher has.
Oh yeah.
Oh, that keeps them busy for hours.
Dude, those things are cool. The entry project for thermal dynamics, their first project at Dartmouth is to build a steam engine. No, a Stirling engine. And they have to it has to weigh a certain amount, has to put out a certain amount of power. And so that's a pretty cool project they got going there. And so machining all those parts is a really good way to get started, pretty cool thing. Oh, here I have some photos I could share with the model train thing, and then we'll get going here. Sorry to hold it up. There we go. That's the old, and they take it serious over there. They got like a whole town and like a scene. There it is, New York Society of Model Engineers.
Like, keep that up. Put that up back there. I gotta take a picture of it. I'm gonna ask him tomorrow.
Yeah,
he's never heard of it.
Oh, and that's part of the problem is that people have these machine shops and these cool things, and they don't really know how to market it and get the younger generation involved. Not for nothing, but it can't just be like an old guys club. And they know that, and they do have programming. Because you can actually control it from these computers, could turn on and off all of the tracks. And believe it or not, the trains, they're not just, this is the funniest thing about it, they are not just DC. They actually are, they send a signal over the track to turn on and off different components. So for instance, you could have a steam whistle, bell, you could have music, you could have lights. All that is through programming and code sent over signal over the track. So it's not just, it's not the rheostat days anymore. These trains are pretty, they stepped up their game a little, which is pretty cool. So anyway, pretty cool thing. And we'll wrap it up right there, and I'll see everybody next week. I'll end the recording. I'll probably hang out for like a couple minutes, but end the recording here. Thank you so much.